I am Dr. M.D. Sirajuddin. On behalf of Vaageswari College of Engineering, I welcome you all the participants to this day 3 of 6 days online faculty development program. I take immense pleasure to invite our eminent speaker of today's session, Mr. Raj Verma, Security Engineer, RV Technologies, Hyderabad. Mr. Raj Verma has 13 years of industry experience in designing, implementing security enterprise system. His expertise covers network and application security, identity and access management, vulnerability assessments, penetration testing, and cloud security platforms like Amazon Web Services, Azure, and GCP. He is a certified security engineer with advanced qualifications in cloud and cybersecurity standards. He has worked with reputed clients such as Excel Valley, Wipro, and so on. Raj Verma, skilled in incident responses, security automation, cryptography, endpoints protection, and DevOps practices. He also has hands-on experience with Docker, Kubernetes, GitLab, and so on. With strong problem-solving skills and communication skills, he focuses on building resilient and quantum-ready digital ecosystems to meet evolving cybersecurity challenges. I would like to involve today's eminent personality, Speaker Raj Verma, sir. Sir, over to you, sir.
Mohammed sir, thank you for your introduction. Okay.
You're welcome, sir.
Good evening. Yeah. Good evening, everyone. I hope everyone is well, right?
Yes, sir. Your PPT is visible. Your voice is clear. Please continue.
Okay. So, coming to our topics today, our topic is quantum computing threats and threats to cybersecurity. Okay. So, before going to start, so nowadays we are all living in a digital world, right? So, like we are using the UPI, Aadhaar, digital lockers, WhatsApp, Paytm, SBI net banking. So it means that we are all are depending on online systems. So even though from the kid to the older person as well, so we are using mobile phones like internet, right? So but if I tell you in a 10 to 15 years, a new kind of computer called quantum computer can break all these of protections. So how it is it scary, right? So for that, we have to learn quantum computing and cyber security. Is it clear? I hope you are. Everyone is getting my voice, right? Say, sir, are you
Yes, sir.
getting my voice?
Yes, sir. You are
Yes.
clear, sir. You are clear, sir. Please continue.
Done. So, for example, in the 2019, the Google quantum computers, like we have a name with that, Psycha-More. So solved in a problem in 20 seconds. Okay, so that would be take a supercomputer around, it will take to solve 10,000 years. Imagine what happened when such a power is used against banking or other systems. So I think if the person is facing any banking issue or else any other issue, it will resolve in seconds. When if nowadays we are going to other centers bankings regularly, right? So it will take around 1 to 2 days to solve it. But a supercomputer comes, like a quantum computer comes, it will be solved in 1 to 2 hours. If any problem, okay. So that's why this seminar is very important to understand the risk, how it is works, and what we can do with using these quantum computers. Okay, I think I am clear. So I hope you understand as well. But then, first of all, what is quantum computing? So what is quantum computing? It means, so quantum computing is the next level technology based on the quantum mechanisms. As you are all are aware of that, normal computers. So it are working with bits 0 or 1, right? So in the same way, quantum computers are used qubits. So qubits which means that they have 0 and 1s and the both as well. So like superpowers or superpositions. Okay. So think like an example. Okay. Think if it is like in a coin, right? So a normal computer or normal bits like in a coin kept flat, either it shows heads or tails, right? So but a qubit or a quantum computers, okay, it if it is it's look like a spinning coin. It means that it's having both the heads and tails. Until you stop it, it will run the same. Clear? Right. So this is a special power makes the quantum computers extremely fast in solving the tough problems as well. Okay. So why it is so powerful? So why the quantum computer have this much power? Means that I conclude with the 2 points. So because of qubits can be entangled, like it have lots of sharing information instantly. Like the here the like we are if you are sharing some information to somewhere like in the world, it will take around 1 to 2 minutes or 1 to 2 more than 5 minutes as well. Like in the department depends on the size of the file, right? So, but here the size doesn't matter and the distance doesn't matter. It will share immediately in instance only. Clear? Then in the same way, the next power of the quantum is parallel calculations. So in general computer will take the calculations for some few seconds, right? So, but the quantum computer will take the calculations within the seconds. It will complete the within in the seconds only. So they can test millions of solutions at once. They can randomly test millions of the solutions at once. Okay. So in real example, so take an example as IBM. So IBM already already worked with the quantums, right? So they have own test lab as well. So IBM is latest quantum system have overall around 400 qubits, I think so. I don't know exactly. So by 2025 or to 2030, they expect to machineries within the 1,000 plus quantums. So once we across 1 plus million qubits, estimated in 10 to 15 years, so the RSA, we are using RSA and ECC encryptions nowadays. Those will be broken like anything. Those will be not at all work for the quantums. Clear? So like in a let's take a normal example. Like everyone using nowadays IRTC booking, right? So nowadays we are all are using more like what is that? Abibus, Make My Trip. Like we are using n number of applications, right? So whenever millions of people are completing the booking, okay. So now we are using classical computers only, right? So the classical computers are allocated tickets within the seconds. But a quantum system is involved in that booking, it will provide the solution within instantly. Okay. So showing how it is powerful. So that is a difference between the local computer, like classical computer and the quantum computer, right? Next. I hope my screen is visible, right? Sorry. Done? The slide is changed or not? Yes.
Now it is
So,
changed, sir.
yes. Today's our agenda is so fundamentals of quantum computing, so cryptographic vulnerabilities, post-quantum solutions, and implementation roadmap. So we will cover all these things in our session. Okay. So as I said, the quantum computing power and all the things, right? And as I said, the IBM things as well. Okay. Right. Next. So with using these quantum computing, we are facing any issues or our further generations. Yes. So even though in our cyber security, so in our security is also being in risk only. For that, I will conclude within short and sweet. Okay. So current encryptions we are using RSA and ECC and define elements. So RSA is generally used for Aadhaar and banking websites and digital signatures. Okay. The same way ECs are used in WhatsApps, buttons, UPIs, and the Paytm, as you know, Bitcoin as well. So we are using n number of encryptions like this only. So in the same way, we have a DeFi element. So DeFi element is used in VPNs like Cisco's government secure common websites. Okay, done. So these all are generally we are using nowadays. So today the security like RSA, as I said, RSA and ECC depends on mathematical problems that are very hard for the normal computers. Okay, the basic example of that is the RSA security is depends on breaking a very large number into the prime numbers. Okay, so even though ECC is use very complex algebra with elliptic curves, right? Okay, then the classical computer takes thousands of years to solve these things. A normal computer will take the thousand of years to solve these things. What I said before, it will take around thousand of years. But take an example in a real time. It try to guess. Take an example. Try to crack the ATM pin, 4-digit ATM pin. It will take ages for the normal computer. It will take around 10 to 15 years. So, but in the quantum computer, can crack it much faster using special algorithms. Okay, right. As I said, RSA encryption, okay, ECC and DeFi element key exchange. Done. So, take another example for that in the same way. So when you are logged into SBI networking, your data is encrypted using RSA. Your data is encrypted using RSA. Today's supercomputers needed trials of years to break it, but a quantum computer can do it in an hour. Do it in an hour. Okay, so this is the power of quantum computer. So that's why the quantum computer is very fast generation computer. Done right. So for that quantum computer, the world is introduced to algorithms. So that is one is Shor's algorithm and next one is Bruce algorithms. So I will discuss later these things. Then right. Next. So how impact is it from the quantum computer is? So that is nothing but harvest now, decrypt later. Okay. So I will show that one as well. Okay, even the last one. No worries. Then no worries. The slide is missing. Yeah. So I conclude within a short way. Even a hacker or a foreign agencies are already collecting encrypted data today. Okay. So they are already prepared to hack the data. So that's why they are collected data today only. So in 2035, when the quantum computers mature, they will unlock all those files. Clear? So in the real example, imagine Pakistan or China secretly recording our encrypted Indian defense communications today, only to decode them in a 10 years or after 10 years. That is a very serious national security risk we have to face. So that is a very big problem to our nation. That's a very much effective to our nation and the world as well. Okay. So next. So how quantum computers break encryptions? So how it will be shows. So as I said, we have two